Hello class, this is the last segment of our context component, and today we are looking at origami for life. So we are going to explore how origami can make our world better, and we are going to look at origami and architecture and also medical origami. And I think you recognize that object on your right. We're going to talk about that too. So origami and architecture, it's been applied to architecture for both structural design and aesthetics, which is beauty. For structure, it's not only how you build it, but it's also to create modules or parts that can be fitted together easily in order to make a whole. And the aesthetics, the origami forms are viewed, they're graceful, they're futuristic, and they have some practical, sensible uses as well. So first we're going to look at some of the very famous origami-based buildings. This one is in Spain, and you're looking at it from the interior. Over here we have got the house that's in Australia. It's the Bottle House. And the embedded project in Shanghai, China. And you're watching that be constructed. And they actually kind of fold things by crawling up and down the scaffolds and then attach the modules to each other. This is the Helios House in Los Angeles. It's a gas station. And the health department in Bilbao, Spain. You can see the divisions on this. The Helios is mainly triangular divisions, while the health department has some of the more complex shapes to create the form. But while those buildings are beautiful and useful, origami is really being pushed as a way to design inexpensive, sustainable, portable housing. And that is very important because it can be used as emergency housing when there's a natural disaster of some sort. It can be used as shelters for the homeless, and also to create tiny homes and campers as people tend to move towards smaller living spaces. These are some of the models and that are developed. There is actually design contests for university students for designing this type of structure. And you can see by looking at it and seeing the inside of it how the pleats work and how it would collapse, even though this one and this one, they're slightly different, how it would collapse down into a very simple shape. So here are a few of the designs that are being used. The pump and jump is made for mostly homeless people. And it can convert and fold up so that it's just the handles with that arch and then two wheels with the two smaller wheels, sort of a flat surface. That can be unlatched and extended. You can see the two wheels down here so that they can pile belongings on it or use it to collect things. A lot of homeless people collect things like bottles and scrap metal that they can turn in for money. And then that back part, you can also unlatch and extend like an accordion and pump it, and there will be your sleeping quarters. Over here, this is a similar type of idea in that it folds into something that is easily taken with you. In this case, it's more drug along than pushed. It's a little bit less easy to travel with, but it functions in some different ways. It can provide you with something to lean against for sitting or shade for sun, complete coverage for at the nighttime, and then you can fold it and reverse it so that you can store items in here to carry. And at the bottom is one that is being developed more for emergency shelter after natural disasters. And it's heavy-duty industrial cardboard, but it still pops up very quickly, but it's heavy enough that it's going to be a little bit more stable, especially when you interlock them. When you put them side by side, very close, you can slide these kind of structures in proximity to each other and then clip them so you create a big stable pod. And then here is one of my favorites. It's the origami tiny house. It can be delivered by a truck and unfolded and set up in 3 hours. Now that's not with furniture inside. It's naked on the inside. It does have stairs to get to the top level, and it has everything set up as far as the conduit or places where you have the wiring and plumbing and things of that nature. You just have to hook it up. So it comes as a box, and then using the crane type thing and some jacks, it quickly converts into this cute little house that I could live in. The largest size they make is just a little bit smaller than the house that I actually live in, which isn't a design tiny house. It's just an old house. There is a video attached to Classroom so that you can actually learn more about this and watch it in action. And there's a video that's a little bit longer that talks about a different type of foldable house. Origami on the inside is the biomedical origami. And this is designed to be used inside your body. It tends to be extremely tiny, which is its whole idea. So things like what you see over here on the right are the chemotherapy implants that once they're made to deliver medicine, they're inserted into the body, and some of them are robotic, so they can crawl to the exact place that they're supposed to be. And once they're there, they unfold and start pumping the medicine into your body. There's devices that assist with surgery, so that instead of having to cut you open to get some things done, what they do is put a very small tube in and the origami device, and then once it's inside, it opens up into whatever shape it is, and it can be controlled remotely. Catheters and shunts to help the body work better, to open up things like blocked arteries, and exploring robots that figure out and solve problems from the inside. So here are some diagrams that show some examples. At the top, you have an origami folded sheet that is implanted into the eye to help improve vision. You have an origami replacement disc that can be implanted in between your vertebrae in your back to, if you have a ruptured disc or a fractured disc. And then there are these super cool little tiny robots that are ingested in ice. So think about taking a pill, but the pill's made of ice, so it's easily to swallow. But then it melts inside your body, and the little robot unfolds, crawls out, and can do things. It can deliver medicine, it can treat you, but these were really developed to solve the problems of little kids swallowing things that they aren't supposed to, like batteries and magnets. Magnets are really dangerous because when little kids swallow them, if they swallow more than one, the magnets can stick together with skin in between them, and that can cause some serious problems. So little robot here kind of crawls around and dislodges things and just kind of crawls them right out of your system. Origami is being used to design better face masks, and this is one of them. It's the origami mask. And it is designed with all those, see those layers and folds and pleats. It fits your face tighter but it's more comfortable because instead of fitting quite so closely to your nose and mouth, it creates a dome, like a shelter. And because it has all those folds and pleats, it has a larger surface area. So it's much more efficient at trapping particles, both from the inside and the outside. So your assignment is to make a simple mask. This is not going to be a mask that you could use to actually prevent transmission of things, because we're using rudimentary materials. In order to make this to be effective, you would have to use the right kind of filter papers. But this is how those disposable masks that you wear are made, except for they use elastic around the ears instead of paper. So this video tutorial is very good. It's easy to follow. Slow it down. I would suggest use that little gear on YouTube and go to settings and go to playback speed and reduce it down to 0.25 if it's moving too fast for you. Also pause it in places. And when she is using tape to secure the sides and to secure the part that goes around your ears, she's using an adhesive that you put on and then you pull off and it leaves a sticky surface. Because these are not functional, they're just models, so you learn how these masks are made, we can just use regular tape or even leave that out. I just care about you folding the main part of the mask in order to understand how our masks are made. Okay? That's it. Thank you.